Hello, this is Susan Poss at Spartanburg Community College. This is section 5.4, and this section is dealing with adding and subtracting polynomials. Now, let me preface this with, we just spent a lot of time in the previous sections learning how to multiply. We used all those power rules, we used all those multiplying like bases rules, dividing like bases rules, where we were adding and subtracting and multiplying exponents. Excuse me. In this section, we are no longer multiplying like bases or dividing like bases. We're going to be adding and subtracting. And you're going to notice here that when we look for like terms and we add or subtract like terms, we are not going to change the exponents. So in this section, you should not be adding exponents, subtracting exponents, or multiplying exponents. We're only going to be working now with the numerical coefficients. All right, so we're going to be combining like terms, and I wanted to refresh your mind on like terms. They must have exactly the same variables. And on those variables, I'll just abbreviate variable there, we must have exponents that match. Oh, that didn't turn out. Must have exponents. How about must have matching exponents? That'll be good. All right, so we're looking for letters that are exactly the same in the term. We are looking for exponents that are exactly the same when we're looking for like terms. All right, so here are a couple of addition examples, and I know it looks pretty cluttered here, but I thought this would save me the time of having to write all this down. So you'll notice there are parentheses in the original problem. Notice that the parentheses are not right next to each other. They're not written side by side. They are separated in here with the addition operation. Now you've got to train your eye to look for the operation. Obviously, if you have parentheses that are written side by side, that means something else. But when you have parentheses with a plus or a minus in the middle, that means we are doing an addition or subtraction operation. All right, so the first thing I did here, you see it outlined over here on the left, is I removed the parentheses. So in this line where I've written it all down, you'll see that the parentheses are gone, and I've just simply copied down each of those terms. Right, so I've highlighted using my different colors here the like terms. The first ones are 5x cubed and 4x cubed. Those have matching variables and matching exponents. So I'm going to go ahead and combine those. And notice that the part that combines is the numerical coefficient, and the base and the exponent remain the same. All right, so the next two that I've highlighted here with this light green are negative 8x squared and negative 2x squared. Again, the same variables with the same exponents. I'm going to combine those and get negative 10x squared. And again, the only part that I do any work with are the numerical coefficients. The exponents and the base remain the same. All right, so let's look here, the ones that are highlighted in yellow. Here's a positive 12x, and down here I see a negative 5x. Those are both first degree x's, so I'm going to combine those and get positive 7x. And then the last ones that I see here, I don't know where I got that color from, a gray. Positive 13 is a constant, positive 14 is a constant. Those are like terms, so I'm going to combine those and get positive 27. Right, so we end up with a polynomial here that's got 4 terms. You're going to stop right there because these 4 terms are now all different. They each have this well, 3 of them have the same variable, but all of the exponents on those variables are different. So this is where the problem ends. We end up with a third degree polynomial, and let me make another little quick note here just in terms of review. The lead coefficient on this, that was a term that we learned last time. I'm going to have to abbreviate that. The lead coefficient is 9. So you look for the highest exponent on the variable, and you go for the coefficient in front of that. All right, second one, very similar. You can see that the original problem starts out with parentheses, connected in here with addition. So the first thing I'm going to do is remove the parentheses. All I have to do there is copy down the terms that were inside the parentheses. And again, you can see that I've highlighted the terms that are alike. So remember, this is a 1x cubed added to a 4x cubed gives me a 5x cubed. A positive 5x squared and a negative 1x squared gives me a positive 4x squared. A positive 5x and a negative 8x gives me a negative 3x. And then out here on the end is the constant positive 9. He does not have a like term, so I just write him down. And this ends up being a third degree, again, as a matter of reviewing what we talked about last video. This is a third degree polynomial, and I'm going to abbreviate polynomial. And the lead coefficient is 5. All right, so those are 2 addition problems. Now here's the thing that you have to be careful with on subtraction. So you notice that the first step is to remove the parentheses. So here are the parentheses. Let me put that in red so it's a little more standout. Here's the parentheses. Now the operation is a subtraction operation. So what does that mean? That means that each of these signs, as I remove the parentheses inside here, is going to reverse to its opposite. So you can see I've highlighted that. What was a positive 5x to the 4th becomes a negative. What was a negative 2x cubed becomes a positive. What was a negative 5x squared becomes a positive. What was a positive x becomes a negative x, and you can see that the parentheses are gone. Right, so again, I'm looking through to combine the things that match up, that have the same variable with the same exponent. And so when I combine these two x to the 4th terms, I get positive 4x to the 4th. Now I'm looking at the x cubed terms to combine those. Notice that the base and the power remains the same. I'm looking at the second degree terms, combining those. Notice that this negative x does not have a match, and this positive 10 constant does not have a match. So I simply write those down at the end, and also I want you to notice how I'm keeping the degree in order. That's an important habit to get into. I'm leading off, whoops, I don't like the way that looks. Let me try that again. This term is a degree 4. This term is a degree 3. Here is a degree 2. Remember, this one is a degree 1. And actually, since there is no variable, you could think of that as an x to the 0, which is equivalent to 1. But that's a degree 0. This is called writing it in descending degree. You start with the highest degree and work your way down to the lowest. All right, the second subtraction example. Here are the parentheses. Here's the subtraction in between the parentheses. And you'll notice that I'm going through what was a positive 13x squared becomes negative. What was a negative 6x becomes positive 6x, which was a negative 6 becomes a positive 6, and the parentheses are now gone. So that's our first step. Now I'm looking to combine the two second degree x's. I don't see a match for the first degree x, so I'm just going to write down the positive 6x, and then the two constants will combine to give me positive 1. This turns out to be a second degree trinomial. Remember, 3 terms, trinomial, with a lead coefficient equal to -4. All right, so I'm going to split the section right there. We're going to stop and come back.